Welcome everyone to the A4Q World Congress today. Welcome Adam Leon Smith. I'm so happy to have you here today. Adam is chair of the British Computer Society Special Interest Group in Software Testing, which is the biggest non-profit testing group in the UK. He is Chief Technology Officer of Dragonfly, a European consultancy training and products company that specializes in the intersection of AI and quality. Adam also runs regular training courses in testing, test automation, and testing issues related to AI systems. Thank you, Adam, for being here. I'm happy to hand over to you now.
Thanks, Helena. Thanks for having me. Okay, so hi, everybody. I'm here to talk about AI quality and testing and the intersection of these matters. Now, I've given a talk like this before, but yesterday, the European Union draft legislation on AI was leaked. There's an 82-page draft law, which is mostly about testing. So I'm going to try and cover a bit about that as well today. So I've got a lot to squeeze in. So apologies if I go quite quickly. So who am I? As Helena said, I'm CTO of Dragonfly. So we do consultancy and training. We also build an AI product called Neuro. And I'll show you that briefly later on before I get onto the legislation. I'm also director of a not-for-profit called For Humanity, which is all about technology for humanity, as well as having various roles within the International Standards Organization looking at AI issues. So we've all heard of artificial intelligence. It's the new thing powering business. It's everywhere. It's in your devices. It's in your home. It's in your workplace. It can loosely be defined as taking acquired knowledge to make decisions in contrast to being programmed using explicit logic in the classical programming way. Because of this, it has unique quality issues, and therefore there are specific testing techniques, specific testing challenges that apply to AI. Society is concerned about AI, as evidenced by the legislation I just waved across the screen. And it's really important to show that AI can be trusted with important decisions and be implemented in a trustworthy way. So machine learning is a big part of AI. It's not all of it, but it is the reason that AI has really come on leaps and bounds in the past couple of decades. And one of the things that's really different, I hope you can see my cursor. Yeah. So with traditional software, we have code and we have input data and we have output data. We're all familiar with that. With a machine learning system, we have model hyperparameters, we have input data, and that creates a model. And then we apply code, and then we apply input data to get output data. So there's extra bits in the system, and there's extra processes that we need to be aware of in preparing those bits and testing them. So machine learning is the most common AI method. And machine learning engineers think it's difficult to test as well. It's not just testers. Surveys of ML engineers in Japan have identified that the biggest challenges in integrating ML is decision-making with customers and testing and quality assurance. And a lot of this is about the inherent imperfection that exists within machine learning. It is quite dumb. You throw data at it and it predicts future events will occur based on the data it's seen. You might be familiar with the term Oracle. Test Oracle problem. Many of the challenges that relate to machine learning relate back to an Oracle problem. And there's quite a few different reasons for that. And some of the testing techniques that are commonly used are specifically about working around that problem. Within machine learning testing, this is a chart that illustrates the amount of research papers that have been dedicated to solving some of these testing and quality problems. Some of the problems are around specifying the criteria for when it's good enough, when it's adequate, acceptance criteria, if you like. There's research as well around boundary identification. Things like boundary value analysis don't work in the same way when you're applying them to something like a neural network. There's problems around debugging. It's very different. It's very different. Explaining why something, a machine learning model did a particular thing can be quite challenging in a specific instance. As I said, an Oracle problem is a very common area that gets a lot of focus, a lot of research around that. Regression is completely different. When we do regression testing, we typically do targeted regression testing, looking for ways that the software's gone backwards. But when you retrain a machine learning model, you can't target it like that. The whole model can change. And none of this stops at go live anymore because models keep changing and they keep adapting to new circumstances in some cases, or the data might change, or the real world might change. So you need to continuously test and monitor in a production environment as well. So let me take you through some of the high-level quality problems that we have with AI. First of all, if there's less specification required to produce software, if we're just throwing data at a model and telling it to give us the right answer, how are we going to define our tests? Because we haven't sat down to determine the specification of the software. That's the first problem. The second problem is, what if we don't know the answer? If we're writing the AI system to determine the answer for something that isn't currently known, how are we going to know if it's right? Test coverage is very difficult to measure. Lines of code isn't an effective way of measuring the coverage within something like a neural network. There is approaches, and I'll cover some of them later, that use the coverage of the neurons itself within the neural network to determine whether the testing is adequate. What if your tests change the system? This might be fine. This might be something you can just work with your data scientist on to make sure you're starting at a baseline whenever you run your tests. But what if you're using a third-party service like Amazon or Microsoft? What if your automated tests are affecting the behavior of the production system? I've seen this happen with natural language chatbots, where you run automated tests running all the same queries, and the system overfits to what's in your tests and starts to perform less well to things that other users might ask. If we're trying to mimic humans, what are human capabilities? What are we trying to mimic? Defining human intelligence is hard enough. There's no single definition. There's lots of different types of modalities of human intelligence. But a lot of the time, we want something like a chatbot to mimic a human, but sitting down to actually define what that is quite hard. Another problem is that algorithms are most effective when designed for a specific scenario. So if you take an algorithm that's been designed for one scenario and try to apply it across all possible scenarios, you will find that it is not robust. And this is really the difference between the AI that we have now and the AI in the sci-fi books that we're kind of aiming towards in 30, 40 years, the strong AI or the general AI. The ability to take learning from one context and transfer it to another context. Bias. Bias is an issue, and it's a very complex issue. All machine learning models are biased towards the data used to train them. And in fact, bias is both a good thing and a bad thing. We want machine learning models to make different decisions based on what they see, and that is bias. But also, we don't want the outcomes to necessarily be biased in a societal way that isn't acceptable in our culture or in our state. So bias is a huge topic in itself. And the only way to really determine bias is testing. As I said before, the correlation between inputs and outputs change over time. If I take a model that's predicting how many people are going to park in a supermarket tomorrow, lockdown will have changed that, right? The COVID lockdown has suddenly changed all the correlations and the predictions that a model would make about people moving around in the real world. And it might not be the real world that changes. It might actually be the data that's being fed to the machine learning model changes in some subtle way. And that's why we need to keep monitoring AI systems in a production environment. Is the system ethical or fair? Now this is a difficult question to answer because the laws are different in different countries, even between the UK, the US, the EU. There are different laws about ethics, fairness. In fact, ethics itself divides into a whole set of different ethical systems. There is no one single ethical answer to something. What if it's trusted too much? If humans are using AI systems to support their decisions, such as a self-driving car where a human is still supposed to maintain a level of supervision over the self-driving car, or something as simple as a machine learning algorithm that's pre-populating fields on a screen for someone to approve. Research has shown that human decision-making degrades in that context. It's called automation bias or complacency bias. This is a critical thing to factor into an end-to-end test strategy when you're working with a decision support system. What if it can be tricked? If you give me a facial recognition system, I can create an image that will look to you like a picture of my face, but will look to the machine like a picture of somebody else maybe someone famous, maybe someone I want to impersonate. These are called adversarial examples. You can manipulate AI systems in a number of ways that are unique. So AI systems have different qualities. There's a lot of work going on at the moment to define what those qualities are, but here's some thoughts on them. Controllability is a huge aspect. Being able to step in and override a system, being able to determine the operational parameters at which a system will yield control to a human. Run transparency, which most people call explainability, being able to explain why a system did what it did. And interpretability, how interpretable is that explanation to a user? How robust is a system? How well is it going to work when exposed to all possible types of data? How adaptable is it? How can it be retrained? Does it retrain itself? Does someone do that every day? Does someone do it every month? And how easy is it to do that? What about societal and ethical risk mitigation? How well are we mitigating the risks that the system could cause to society and to people in society? And how well does it cover the context of the target use case? It's very important to realize that it may work very well in a particular use case, but when redeployed to a different use case, a different country, a different set of people, AI systems might work very, very differently. So there was a technical report issued by ISO last year, guidelines on the testing of AI-based systems. And it talks about a few black box techniques, which I'll run through some of them. And it talks about white box techniques as well, including neuron coverage, as I mentioned before. One of the things that you can apply to AI is combinatorial testing or pairwise testing or all pairs testing. And you might be familiar with this technique from testing traditional, conventional software. Basically, this optimizes the parameters of combinations because we know from research that tweaking to one particular pair of parameters is most likely to find defects in conventional software. And it's expected that this remains true as well with AI systems, although the research probably doesn't back that up yet. So you might be familiar with this type of testing. If you're not, I'm not going to have time to fully explain it, but it is a way of optimizing all the different inputs. So if I have a system which has 4 parameters and each parameter has 3 possible values, exhaustive testing would require 81 test cases, but using combinatorial testing technique, that's just 9 test cases that are going to find something like 92% of issues. So what if I apply this to something like a self-driving car? I can look at inputs from all different sensors, the weather, the road conditions, the geography of the area, the light levels, the traffic conditions, the visibility. As you can see, these are all key parameters that I can look at from a black box, in a black box way, and start to apply to design tests. If we apply the same to a neural network, we potentially can get some very good results. And there is some good research on this showing that there is good results. The main challenge with such systems is that they're so complex. They contain so many states, and that state space is so big, it's very, very difficult to do any kind of exhaustive testing. And that's why combinatorial testing is a technique that we can look at using to try and reduce the amount of tests that we have to do. I should say the research covers doing this from a white box perspective. There's no research yet on doing this from a black box perspective, although it is used in practice. Another testing technique I can use, and this is specifically to get around the Oracle problem, is metamorphic testing. So this is a testing technique where you run a test and then run a test changing something and check whether it has a common sense change in output. So a really simple example of this is if I go to something like Airbnb, okay, and I search for flats in the area I'm going on holiday, and I find 1,000. If I tick, it should have air conditioning, I would expect logically to see less than 1,000. Metamorphic testing is more complex than this. That's a very simple example, but it's all about establishing common sense heuristics about how inputs should change outputs, running multiple tests and seeing if that has the effect you expected. We can also use AI to help with testing itself. So one example of this is test data generation. We can use machine learning to take something like production data and output test data that has the same statistical properties, but isn't actually the original data, so isn't necessarily sensitive. We can use it for defect triaging and analysis. This is an app that my team's built called Neuro, and we use this for doing all sorts of management activities with quality and with engineering. And one of the things we can do here is pick up a new defect, and it will automatically recommend who in the team should look at that defect next, and it will allow me to automatically assign it to them. This gets a bit risky because what if I then just keep assigning it to the machine just keeps recommending the same person? They're going to get very busy. So we look at other things like how busy they are, and we offer different options in the team as well. You can use AI for anomaly detection. That's a really good way of analyzing massive amounts of bug reports from something like an operating system. Think about how many bug reports Windows or Chrome gets a day that are generated automatically. You can use AI for generating tests, for exploring your application. There's a whole load of limitations around that. It allows you to cover off some of your testing risks, but not all of them. You can use it to prioritize which tests you should run in order to find the most defects. More popular is probably in the test automation space at the moment. There's quite a lot of companies who are offering some solutions in order to be able to better recognize objects on something like a web page, identify them, to make things like Selenium tests much less brittle. If I had more time, I would demo some of that. I've got some great videos of that in action. You can also use it using computer vision technology to identify visual bugs, comparing systems across browsers, across different devices and things like that. So there's quite a lot of different use cases where we can actually bring AI into testing to help us do our jobs. And one example on test data generation is generative adversarial networks. So have you ever needed a bunch of photos of people in order to test an app? Have you ever gone around and taken pictures of yourself and things like that to do it? Well, now you can go to thispersondoesnotexist.com and get as many pictures of faces as an infinite amount of pictures of faces. Every time you refresh the page, a new face is generated. That helps solve test data problems, and it's also quite good fun. So I'd really recommend going to that website and checking out the quality of those faces. There's a whole bunch of international standards under development around AI, and I would class them under quality and trustworthiness. As I said before, there's a technical report on testing of AI-based systems. There's work on quality models to extend quality models for conventional systems to cover AI. There's lots of work going on bias and trustworthiness, robustness, how we manage risks, and ethical and societal concerns. And these should all be feeding into the testing of complex, high-risk AI systems. So let's talk about the new legislation. So this was leaked yesterday morning. It's due to be issued formally by the EU next week. And in my opinion, it's the biggest legislative change I've ever seen in terms of quality and testing, in terms of its wide impact. Of course, there's laws around testing for safety critical stuff, standards and things like that. But they're normally quite specific areas. The new proposed legislation applies to any system that uses statistical techniques. So that would include any kind of credit risk algorithm, for example, that might use some kind of probability or stochastic process. Also machine learning, and also symbolic AI, what we call expert systems that reason and deduce. It applies to any system that might affect EU persons, so it's extraterritorial. It's like GDPR. It will have a global impact. It doesn't just apply to companies making AI. It applies to people that are distributing, supplying AI systems, and users. And by user, I mean someone whose authority under which the system is used. So that's probably the company that deploys it in order to provide a service to people. So there's a series of things it completely prohibits, although there's a get-out clause for nation states to provide an exception. And that's manipulation of human behavior or opinion, exploiting people's vulnerabilities, indiscriminate surveillance, and social scoring. So you can't do those things. It also identifies a bunch of things as high risk. So safety components, obviously, high risk. Biometric identification in a publicly accessible space, so facial recognition technology that might let you into a building. Emergency responses, the distribution of resources like police or fire engines in an emergency. Access to education and training. Lots of universities use fraud detection machine learning in order to look for fraudulent university applications. Recruitment, lots of startups are doing this. Task allocation, startups are doing this. Evaluating work performance and behavior. Assessing credit worthiness. Eligibility for public services and benefits. Assessing the risk related to a specific person or risk of fraud. And crime detection and prediction. The last two areas are immigration, so assessing visa applications and asylum applications, and assisting judges. It is true that AI systems do help judges sometimes in some countries. So what happens if you're supplying, providing, or using a high-risk system? Well, you're required to do a conformity assessment prior to the placement of that system on the market as it's being put into service, and that's testing. You're also required to register with a central public database. You're required to analyze your data sets to ensure they are error-free, unbiased, and representative, and that you're using representative test data, and that you have a whole set of governance practices around that. You're required to monitor the systems ongoing in the event that they are self-learning or self-optimizing in some way. There's a requirement for logging, which is nice. There's also a requirement to have very detailed technical documentation, and there's 2 pages of requirements for what needs to be in those documents, including detailed testing procedures, including metrics. It requires you to communicate to the users, so the people deploying the system, a lot of things, like how accurate it is, the actual test results. Human oversight and controllability is mandatory to a certain degree. End users need to know that they're interacting with an AI system as well. There's less of an impact on testing, but certainly there's a feature requirement that a user must be told if they're interacting with an AI. If you're producing artificially generated media, and I'm talking about deep fakes here, if you're doing anything that people might think is real, that's not, is AI generated, you have to disclose that. And for all of these requirements, there's a breach reporting framework, much similar to a data breach under GDPR. It permits some things, though, as well. It permits you and encourages you, frankly, to use sensitive data about people for testing, for the purposes of monitoring for bias and correction, which is a big change because there's no current basis under GDPR to use production personal data for testing, but now there is. It provides additional obligations on people to provide a documented technical quality management system. So this is not like ISO 9001. This is a technical quality management system for how you test and how you monitor your systems ongoing. It also provides obligations on users to monitor the system and keep records of additional input data and to carry out a data privacy impact assessment, because some of this is already regulated under GDPR. And once you've done all of this, you need to go and get conformity assessed by an independent, competent professional registered with a national authority. The conformity assessment and the results have to be documented, to be conducted every time there's any kind of modification to the system. And this, as I said, this is not paperwork. This includes physically auditing the data. It includes actual testing where appropriate. And it results in one of these CE marks you see on physical products sometimes being applied to the system. So that was a really quick run through of a really complex topic. If you want to know more on this topic, A4Q offer a great training and certification course on AI and software testing. I also have a podcast specifically on this topic at fuzzyquality.com. And if you want to see more of the product I flashed on the screen that recommends people to fix bugs and does all sorts of other things, you can go to our website, www.myneuro.ai. And finally, any general questions you see if you're watching this later or streaming and not able to type a chat in the comments, You could reach out to me on Twitter. I'm Adam Leon Smith. I think I'm the only one. Okay. Thank you very much. Do we have any questions?
Thank you very much, Adam. For now, it seems like there were no questions asked, and the audience is happy and satisfied. And so I would like to thank you for being here and joining us. And for the audience, I would recommend them to go to our virtual Congress Hall, which can be found on the link, which will be posted in the comments real quick. And oh, now we did receive a comment. Clarita says, thank you, Adam, great talk.
Glad you liked it, Clarita.
Perfect. Okay, thank you, Adam, for being here. And now I wish you a very nice evening. And thank you for being part of the A4Q World Congress.
Thank you very much. Have a great evening, everyone.